Today's lesson is Chapter 3, Lessons 2 and Lesson 3. Our objectives for today are to solve inequalities by using addition and subtraction and to graph the solutions. Then we want to be able to solve inequalities by multiplication and division and graph the solutions. So this is on page 176, so you do not have to copy this table because it is in your book, so if you need to look back at it, you can have that in your book to look at tomorrow in class. Properties of inequalities with addition and subtraction. Addition, it says you can add the same number to both sides of an inequality and the statement will be true. If we look at this in numbers, we have 3 is less than 8. If I add 2 to both sides of that, and I say 3 plus 2 is less than 8 plus 2, I get 5 is less than 10. That's still a true statement. So it's saying I can add any number I want to as long as I add it to both sides, and the statement is still going to be true. And here it is in algebra with just letters. A is less than B, and it's saying that A is still less than B if I add C to both sides. Subtraction. You can subtract the same number from both sides of an inequality and the statement will be true. Again, looking at the example here, it says 9 is less than 12, and it's saying if I subtract 5 from both the 9 and the 12, I get 4 is less than 7, and that's still a true statement. So as long as I subtract or add from both sides of the inequality, my statement's going to remain true. It says these properties are also true for greater than, less than or equal to, and greater than or equal to. Go ahead, take a minute and write down number 1. It says n plus 2.5 is greater than or equal to negative 6. For these problems, we're going to do a couple of different steps. We're going to solve them, set them, graph them, and check them. So you'll hear me say that a lot. Solve, set, graph, and check. So here to solve, we want to get the n by itself. So I need to move the 2.5, and it's plus 2.5, so I'm going to subtract 2.5 from both sides. And n is greater than or equal to negative 8.5. So I've done my first step. I've solved the inequality. Now I'm going to set it, and by set it I just mean put your braces around it and your n such that. We're going to make it look fancy and say, have one of our braces in our bar, that means such that n is greater than or equal to negative 8.5. It says writing the solution using set notation, read as the set of all n such that n is greater than or equal to negative 8 5/10. So we solved it, we've set it in our set notation. Now we're going to graph it on a number line. We always put this number right here, the number that we got, in the middle, and then we're going to put 2 numbers less than that number and 2 numbers greater than that number. So I'm going to put negative 9.5, negative 9, negative 8.5, negative 8, and negative 7.5. Please remember that negatives go opposite than positives here, so make sure that you have these down correctly. We're going to draw a solid circle at negative 8.5. So we've got a solid circle here, and it's solid because it's saying greater than or equal to, and it has this extra mark right here, so we're going to make it dark and fill it in. Also, our arrow right here is pointing to the right, so we're going to shade to the right. And it's also because all of our solutions are numbers that are greater than or equal to negative 8.5. So all the numbers greater than that are to the right of that number. So on our graph, it's showing that negative 8.5 is a solution to our inequality, and so is any number that is greater than that. So we've solved it, we've set it, we've graphed it, now we're going to check it. To check, we do not check with the number that we came up with. It's a little bit different than equations. With equations, we took this number and checked. We're just going to take a number from the shaded region. And the reason that we do this is to make sure that we shaded the correct direction. If I check the number in the middle, I have no idea whether I was shaded the correct direction. So I'm going to pick one of the numbers in the shaded region. We're going to pick negative 8 here. And I always go back to my original equation in order to check, and instead of n, I put in negative 8. Negative 8 plus 2.5 is negative 5.5, which is greater than or equal to negative 6, so that checks out. And as long as it becomes a true statement, then that checks. Take a minute, make sure you have the solve, the set, the graph, and the check written for problem number 1. All right, go ahead and make sure that you have number 2. Okay, number 2 I'm going to show you on paper. Again, you should have it written down. I want to get the D right here by itself, so I need to move the minus 8. So to move minus 8, I'm going to do the opposite, and I'm going to add 8 to both sides. This 8 is going to cancel, and it's going to be D is greater than negative 7. So I've solved it. My next step is to set it. So we're going to put our braces or our squigglies and our D such that around it. So we've solved it, we've set it, now we're going to graph it. Again, I'm going to draw my number line. I'm going to put my negative 7 in the middle. I need 2 numbers less and 2 numbers greater. So I'm going to do negative 9, negative 8, negative 7, negative 6, and negative 5. Remembering that negative numbers go opposite than positive numbers. This time on the negative 7, it's going to be an open circle because there's no extra mark underneath my greater than symbol. So it's going to be open because negative 7 is not a correct solution. And then here it's the numbers greater than negative 7. If I look, my arrow's pointing to the right, so I'm going to shade to the right. And if you want to shade using a highlighter, that's fine. But I do actually want you to shade on the number line and not above it. So that's what your graph should look like. So you've solved it, we've set it, we've graphed it, now we're going to check it. So to check, again, I go back to my original problem, and I'm not going to pick the negative 7 to check with because that doesn't let me know that I shaded the correct region. So I'm going to pick a different number. I'm going to pick a number in this shaded region in order to check. So I'm going to pick negative 6. So I'm going to say negative 6 minus 8 is greater than negative 15. And negative 6 minus 8 is negative 14, which is greater than negative 15, so that checks out. Take a minute, make sure you have the solve, the set, the graph, and the check written for this one. Alright, hopefully you got all that down. Go ahead and write down number 3. Negative 3 is less than or equal to t minus 7.2. Alright, we're going to solve this one. Again, this time our t is on the other side, or on the opposite side, on the right-hand side here. We're still wanting to get that t by itself. So to get the t by itself, it has minus 7.2 on that side with the t, so we need to move the minus 7.2. So we're going to add 7.2 to both sides. Again, we're going to do the opposite. And we get 4.2 is less than or equal to t. Now when we go to set this, we have to set it with the t on the left-hand side. Also, if you're going to shade the direction the arrow is pointing, the variable has to be on the left and not on the right. So we're going to flip this entire thing around and rewrite it. So we're going to put our t on the left and our 4.2 on the right, and we're going to flip that inequality symbol. And I'll actually can say, okay, right here, the alligator is eating the t, and when I turn it around, the alligator is still eating the t, so please make sure that it's still correct in what the alligator's eating here. Or if you say it's pointing to the 4.2, make sure it's still pointing to the 4.2. Again, however you want to remember that. So we've solved it. Now we're going to set it. So we're going to put our braces or squigglies around it and our t such that. So we've solved it, set it. Now we're going to graph it. Our 4.2 goes in the middle, and I need 2 numbers less and 2 numbers greater. So I'm going to say 4.0, 4.1, 4.2, 4.3, and 4.4. Our circle is going to be shaded in or solid because of the extra mark here. And it's going to be shaded to the right because it's talking about all the numbers greater than 4.2, and also the arrow's pointing to the right here. So we've solved it, set it, graphed it. Now our final step is to check it. We go back to our original problem to check. And again, make sure that you do not check with this number. Make sure you check with the number in the shaded region. We're going to check with 4.3. So I'm going to say negative 3 is less than or equal to 4.3 minus 7.2, which gives me negative 3 is less than or equal to negative 2.9, which is a true statement, so it checks out. Again, make sure you have the solve, set, graph, and check written before you move on. All right, number 4, go ahead, write down number 4, and just leave some room. We're going to do this one tomorrow in class. All right, so again, you should have written down number 4. Just leave yourself, again, some room, about as much room as you left for all the other problems. And we're going to work that one out in class tomorrow because it's a word problem. All right, so there's our first objective. We should now be able to solve inequalities by using addition and subtraction. Now we're going to look at multiplication and division. So as you can find the information on the next 2 slides in your book on page 182 and 183, you do not have to copy the tables. This says the property of inequalities. It says multiplication. It says you can multiply both sides of an inequality by the same positive number and the statement will still be true. So if I have 7 is less than 12 and I multiply both the 7 and the 12 by 3, I get 21 is less than 36, and that's still a true statement. So it's basically saying I can multiply both sides of the inequality by the same number. And again, here with the algebra or with the variables, it's the same way. Division says you can multiply or divide both sides of an inequality by the same positive number, and the statement will still be true. Again, if I have 15 is less than 35 and I divide both the 15 and the 35 by 5, I get 3 is less than 7, and that's still a true statement. Okay. Notice that with both of these, I'm multiplying and dividing by positive numbers. That's the key here. It stays the same if you're multiplying or dividing by a positive number. Now we're going to look at what happens when you multiply or divide by a negative number. So this one says if you multiply both sides of an inequality by the same negative number, you must reverse the inequality for the statement to still be true. So you have to be careful with multiplying and dividing by negative numbers, and that's what makes solving inequalities different than solving equations. So here, if I have 8 is greater than 4, if I multiply both sides by negative 2, I get negative 16 and negative 8, and I have to flip this inequality sign around for it to still be true. So anytime you multiply by a negative number, you must flip the inequality symbol. If you divide both sides of an inequality by the same negative number, you must reverse the inequality for the statement to still be true. So here I have 12 is greater than 4, and if I divide both of those by negative 4, I get negative 3 and negative 1. For this to be true, negative 3 is less than negative 1, and I had to flip that inequality sign over. So basically what this is saying is anytime I multiply or divide by a negative number, I have to flip my inequality symbol around. It says caution, do not change the direction of the inequality symbol just because you see a negative sign. Okay? Just like here on this one, I see a negative right here, but I'm going to divide both sides by a positive 4. So you have to make sure that you're multiplying or dividing by a negative number and not just seeing a negative sign. All right, so go ahead and write down number 5. 12b is greater than negative 18. Here I need to get the b by itself, so I need to move the 12, and the 12 and the b are being multiplied, so I'm going to divide. And here I'm not dividing by a negative number, I'm dividing by a positive 12, so my inequality symbol is going to stay the same. b is greater than negative 1.5. I'm going to set it using my braces and my b such that, so I've solved it, set it, now I'm going to graph it. My negative 1.5 is going to be in the middle. I'm going to have 2 numbers less and 2 numbers greater, so negative 2.5, negative 2.0, negative 1.5, negative 1, and negative 0.5. I'm going to have an open circle around my negative 1.5, and I'm going to shade to the right because we're talking about numbers that are greater than negative 1.5, and also because the arrow is pointing to the right. So I've solved it, set it, now I'm going to graph it, or I've graphed it, now I'm going to check it. Again, don't check with the number that you get here. Make sure that you pick a number that's in the shaded region. I'm going to pick negative 1 here and say 12 times negative 1 is greater than negative 18, which gives me negative 12 is greater than negative 18, which is a true statement. Take a minute, make sure you have the solve, set, graph, and check for number 5. All right, go ahead and make sure you have number 6 written down. I'm going to go ahead and show you this one on notebook paper. Number 6 says 1.3 is less than or equal to negative x. The first thing I'm going to do with this one is I'm going to put me a 1 in front of that x since there's nothing there. Then I need to get the x by itself, so I need to move that negative 1. So I'm going to divide both sides by negative 1. Now, if you look, I just divided by a negative number. So anytime I divide by a negative, my inequality symbol is going to need to flip around. So it's going to go from less than or equal to greater than or equal to. So you're going to flip that over. 1.3 divided by negative 1 is going to be negative 1.3. To set this one, I'm going to have to turn it around because, again, we need the x or the variable to be on the left. My negative 1.3 is going to be here. And I'm going to look and I'm going to say the alligator is eating the negative 1.3, so I'm going to make sure that the alligator is still eating the negative 1.3 when I rewrite it. I'm going to put my braces or squigglies in my x such that for my set. So I've solved it, set it, now I'm going to graph it. My negative 1.3 goes in the middle. I need a number, 2 numbers less and 2 numbers greater, so I'm going to say negative 1.5, negative 1.4, negative 1.2, and negative 1.1. I'm going to have a closed circle around my negative 1.3 this time because I do have the extra mark right here. And it's going to be shaded to the left this time because that's the way the arrow is pointing, and also because I'm looking for numbers that are less than negative 1.3. So there's my solve by set my graph. Now finally I'm going to check it. I'm going to go back to my original before I divided anything, before I flip my symbol. And again, I'm not going to pick negative 1.3 to check with. I'm going to pick a different number that's in my shaded region. So I'm going to pick negative 1.4. Again, this is just so that it lets me know that I shaded the correct direction. So I have 1.3 is less than or equal to negative 1 times negative 1.4 is a positive 1.4. And 1.3 is less than or equal to 1.4. That's a true statement, so it checks out. Again, make sure you have the solve, set, graph, and check written down before you move on. All right, number 7 says m divided by negative 4 is less than negative 12. So go ahead and make sure you've got that written down. All right, so this one I'm going to solve. I need to get this m by itself. And I have it being divided by negative 4. So the opposite of division is multiplication. So I'm going to actually multiply both sides by negative 4, or negative 4 over 1. Now again, if you look, I've multiplied by a negative number. So this inequality symbol is going to have to flip around. So we're going to reverse that symbol. It's going to go from less than to greater than. So m is greater than 48, because negative 12 times negative 4 is a positive 48. I have my m such that with my squigglies or my braces around it for my set. So I've solved it, set it, now I'm going to graph it. I have 48 in the middle here. I need 2 numbers less and 2 numbers greater. So we're going to put 46, 47, 48, 49, and 50. I'm going to have an open circle this time, because there's no extra mark underneath here, so 48 is not included in my answer. And I'm going to shade to the right because I'm looking for numbers greater than 48. So all of my solutions are all the numbers that are greater than 48. I can plug in any number greater than 48 into my inequality and it's going to be true. So I've solved it, set it, graphed it. Now I'm going to check it. It says you must check the original problem. Now again, you can choose to check with 49 or 50 here, but you're going to end up with a decimal. So I'm going to choose to go on down my number line and pick the number 54 because I know it's divisible by 4 so that I won't end up with a decimal. Either way that you check it is fine as long as you use a number within the shaded region and you do not use 48. So 52 divided by negative 4 is going to give me negative 13, which is less than negative 12, so that checks out. But again, you could have used 49 or 50 to check with. Take a minute, make sure you have the solve, set, graph, and check written before you move on. All right, we're going to look at number 8 on paper. So we're going to say negative 10 is greater than or equal to 2 over 5t. Again, I need to get that t by itself, so I need to move the 2 over 5. And the mathematically correct way to move that fraction, I don't divide by 2 over 5. I'm going to flip it and multiply. So I'm going to multiply both sides by 5 over 2. That way my 5's cancel and my 2's cancel. And this time, my inequality symbol is going to stay greater than. It's not going to flip because the 2 over 5 was a positive 2 over 5. And then when I say 5 over 2 times negative 10, I get negative 25 is greater than or equal to t. Again, my t is not on the correct side here, so I'm going to have to flip that around. So my t is going to be on the left, my negative 25 is going to be on the right. Now I'm going to make sure here the alligator is eating the negative 25, so I'm going to make sure when I rewrite it that my alligator is still eating the negative 25, or it's pointing to the t, so it's still going to be pointing to the t. I'm going to set it with my set notation or my braces and my t such that. So I solved it, set it, now I'm going to graph it. My negative 25 is going to go in the middle. I need 2 numbers less and 2 numbers greater, so negative 27, negative 26, then my negative 25, then negative 24, and negative 23. Again, make sure you be careful with negative numbers. They do go opposite on the number line as positives. It's going to be a closed circle this time because negative 25 is included in my answer set because it's less than or equal to negative 25. I'm going to shade to the left because I'm wanting numbers that are less than negative 25 and because that's the way my arrow is pointing. So I've solved it, set it, graphed it. Now I'm going to check it. Again, make sure that you go back to the original to check. So I set it up, and instead of my t, I'm going to find a number that's on down my number line that is divisible by 5, since 5 is in the denominator. Again, you could use negative 26 or negative 27, but you're going to end up with a decimal. So I'm going to pick negative 30, or I could say negative 30 over 1. And I'm going to get negative 10 is greater than or equal to negative 12, which is a true statement. I'm going to show you what it looks like when I do check with negative 26. You do not have to write both checks down, but I want you to know that it is okay to check with a number that's not divisible, and you can still get a decimal, and that will be just fine. So I'm going to say negative 10 is greater than or equal to 2 over 5 times negative 26. And I'm going to get negative 10 is greater than or equal to negative 10.4, which is still a true statement. So again, either way you want to check with, whether it's a number divisible or not, both of those checks will work. So take a minute, make sure you have the solve, set, graph, and check written before you move on. Yeah. All right, go ahead and write down number 9 on your paper. Again, we're going to come back and do that one in class tomorrow because it is a word problem. So go ahead and write down number 9 and just leave yourself some space. Again, about the same amount of space that it's been taking you to write down the rest of them should be just fine. Okay. So now we've covered our second objective, which means you should be able to solve inequalities by multiplication and division and be able to graph the solutions. Okay. Take just a minute and see what you can do with the before you go. On 1 and 2 it says solve each inequality and graph the solutions. And on number 3 it says 2 students solved an inequality and they have 2 different answers. Who has the correct answer? Explain. So take just a minute, pause your video, and try 1, 2, and 3, and then I'll put up the answer so you can see if you got those correct. Okay, hopefully you've paused the video and you've tried these 3 on your own. You can just ignore the homework thing at the top there. All right, go ahead and check these. On number 1, you should have gotten y is less than or equal to negative 8.8. Number 2, you should have gotten x is greater than 20. And your graph should look like this. You should also have it set and checked. And on number 3, it says Sue is correct. Sam, reverse the inequality symbol. Only reverse if you are multiplying or dividing by a negative number. So here, the 5 was not negative, and that's what I would have been dividing by. The 5 was positive, so my inequality symbol should have stayed the same, which is what Sue did, so she is correct. Sam should not have flipped that sign. So make sure you have all those correct. If not, please go back and find your mistake and fix it. And this is the end of your video. Thank you for watching.